All right, we're back, and it's COMP100, and it's week 8, lesson 8, part 2. And when we last left off, we had been talking about while loops and for loops. We took care of those two things. While loops and for loops, we took care of those things. We should really talk about nested loops a little bit today as well, right? That's important for us to do. And do loops. So those are the two things we're going to handle today. And then we're going to move on to arrays. We're going to start arrays today, see how far we get, and then maybe next week we'll continue a little bit. Let's take a look, right, how this thing goes. So let's go to the do loop. So I'm going to go to do loops. So a do loop is like a while loop, right? A do loop is like a while loop, but it checks stuff out at the bottom of the loop as opposed to the top. Let's try this out in here in Visual Studio. So I'm just going to go in here, and we're going to kind of enter this one here. I'm going to go into new project. Why don't you follow me here, guys? New project. Again, I'm going to hit a console application. Right, we're going to call this COMP100. Right, lesson 8, part 1. Okay, COMP100 lesson 8, part 1. And it's a new console application. I'm also going to kick off a GitHub repo, right? Because I think it's important for us to do this GitHub repo stuff. There we go. And inside GitHub, we're going to go COMP100, right? Lesson 8, part 1. Okay, I'm going to go create my repository. And inside my repository, I'm also going to grab this URI, go into my program, right? I want to go to Team Explorer, changes. I'm going to say created base VS C# project. And we're going to go home and then click unsync commits, Control V, and publish. Okay, cool. Let's take a look. So if I go to GitHub and refresh, then we should have an assignment for you. We should have this test that we're going to do today, this little demo. Okay, so we covered while loops, and you know we keep doing the same thing over and over again. We keep doing this like wait for key. I'm just going to make this a little bigger for you guys so you can see it. Yep, how's that? I'm going to wait for key, right? So remember we kind of talked about how to create this like same thing over and over again. Let's do some shortcuts. Shortcuts today. I like doing shortcuts. And the way we do shortcuts is do this, right? If I right click here, take a look. I want to write some shortcuts. I'm going to go to insert snippet, insert snippet. And now there's different kinds of snippets, right? I'm going to obviously do Visual C# snippet. Okay, so I'm going to double click there, and now it's going to ask me what kind of snippet do I want to write. Well, if you notice, right, if I look at different things, these are all the different kinds of snippets that I can include, right, inside my my code really, really quickly, right? So if you see this CW, see where it says CW? If I double click on this, I get this, right? CW. But see what it stands for? CW, right? Well, you can also do the same thing instead of right-clicking and blah, blah, blah by typing this. CW, tap, tap. Try it out. CW, tap, tap. Yeah? That's what I'm talking about. Some speed we're talking about now, right? All right, so now we're going to do console.writeLine. Let's do another one. CW, tap, tap. Right, and inside there we're going to say press any key to continue this time. Okay? Press any key to continue, right? And then we're going to do a console.read key. Too bad there's no CR, tap, tap. It's not like that, something else, right? And by the way, if you want to know what the hotkeys are for this kind of stuff, you can go to Edit, right? If I'm not wrong, or is it View? View, Just a second, make sure I got the right thing for you guys, because I don't want you to I don't want to give you the wrong information. Because what we want to do is we want to add a code snippet, right? So what we're looking for is the code snippet manager, which is might be under tools or team. Yes. What was that? Yeah. See it? So see where it says code snippet manager under tools? Actually, you can reach it also by, see where it says Control K, Control B? That'll get you there too. So let's click this. And if you notice, I'm looking at Visual C#. And if I click under Visual C#, there's a bunch of these shortcut keys. Well, if we go CW, it says the shortcut is CW. And what does it do? It does a console.writeLine. So that's the shortcut for that one. Let's keep going for stuff that we normally do. Like for example, our while loop. While loop, we type while and then tap tap, right? And we do the same thing for the other ones, the ones that are most common. For, tap tap. So you start writing part of it. If, tap tap, right? These are all the ones that you would have for most of these things. Now there isn't any console.readline that's kind of a quick and dirty one that you can kind of do console.readline or read key tap tap. There isn't that way if you notice.
Add what?
What?
You can add it.
You could. Here it is right here. If I do add, right, I got to actually go here and create my own code snippet, right? And we're not going to cover that yet, right? Probably in programming 2, we're going to come and do that. We're going to kind of create our own. We can also import new ones. By the way, Visual C# is not the only language that it does snippets for. We do them for JavaScript, for HTML, for Visual Basic, for XAML, XML, all kinds of stuff. We have code snippets that are built in place so that you can quickly do your work. Okay, but this is really important stuff because now I need to do a console. Well, I need to do a console.read key, right? Because I'm going to wait for any key to be pressed, and then after the key is pressed, right, I'm going to do a console.clear, which actually clears the screen. All right, so that's the first thing. And if I was to test this out the way it is, and I press the key, it kind of clears the screen, and we're gone, right? Let's leave it like this. We don't have to do it anything different. One thing I'd like to change, though, like I always do when I'm with you guys, I'm going to go to Properties, and I'm going to change the color scheme for the actual terminal window, because I think it's just easier for you guys to see as opposed to pure black, right? So I'm going to go into Consoles, make it size 20, and press OK. Nice and big, right? So we need this piece in order for us to do our tests. Okay, that's fine. Now, we did while loops, right? Let's use our newfound shortcut keys. While, tap, tap, right? It kind of creates our whole structure for our while loop really quickly. How about switch, right? Switch, tap, tap, right? Kind of cool, huh? How about other things like for, tap, tap? That's really important. Look at this one. Look what this does. Boom. It's like really, really, really fast, right? Which is important. I mean, it's important for us to do this kind of thing, right? And the same thing goes for other looping structures like do, tap, tap. And this is what a do while loop looks like. A do while loop is like a while loop, but we check the condition at the bottom, not the top. So what does this mean? It means that whenever we run this thing, it runs at least once. At least once. A menu could work okay with this one too, because if the while loop, if the condition is wrong in the while loop, right, as an example, it won't run ever. But for a do while loop, we want to be able to pull for the menu. So if I was going to create a menu with a do while loop instead of a while loop, right, it'd be like the same kind of thing. I would kind of create my console commands. I'm going to put them inside my console.writeLine, right? So I'm going to go CW, bang, bang, right? So I'm going to kind of do one of these. And inside there, of course, when I'm creating my menu, I'm going to do one of these. So I'm going to make my menu nice and pretty, right? And then I'm going to kind of copy this thing for the bottom. Here's the bottom part of my menu. Try this out, Hattie. Okay, so that way you don't, it's easier for us to do as opposed to watch. And here's the second one, the third line. I'm going to take all this stuff out of here in the middle, right? Here's the middle stuff. And in the middle, I'm going to add in my menu choices. So 1, whatever my choice 1 is. First choice. Right? Take a look what this looks like now. Okay? And I'm going to do the same thing for number 2. So it's going to show me my menu at least once. This is what this does when you use a do while loop. Okay, 2. And then, you know what? We'll do 1. Well, this is my second choice. Second, whatever the second choice is. And I'm just gonna format it so that the pluses are underneath each other. And then let's do the third one, right? And here's my number 3 is instead of third choice, so let's make that an exit, right? An exit condition. Okay. So that's my menu. Now I have to ask the user for an input, right? Like for example, enter your selection or something like that. And of course, we're going to make that as a variable inside the main, right? So we're going to say int selection, and we're going to assign it to 0, right? Initialize it to 0. So there is no selection right now. And then inside here, we're going to say selection is equal to convert. We're going to convert it to int32 because that's important for us to do that, to convert. Because remember, what do we get when we read from the console? What kind of data type are we reading? It's always a string, right? So we always have to convert. Always, always, always. Right? So we're going to go console.readline. Console.readline. Okay, so we're going to do that. Make sense? Here's our console.readline. Right? And what this does, it takes selection now. We have our choice in selection. And now when we do our menu, we're going to do a switch statement. Hey, let's do that switch, tab, tab, switch, tab, tab. And my switch is going to be, we're going to be switching selection. That's what our selection is going to be, right? We have a default case, but we also need some other cases. Case 1, break, right? Case 2, break, right? Those are the 2 cases. And then we also need case 3, break, right? So those are the 3 cases we have in our menu, right? Now I'm doing this do while. It says do while true. Obviously this isn't right. We want to do while selection is not equal to what? 3, right? We're going to keep doing this until the selection is not equal to 3. This works fine for a menu, right? Okay. Actually, both work just the same. The only thing is that the do while loop will always execute at least once, whereas the while loop we may never execute, depending on what the condition I'm testing is, right? Okay, here's my case 1. So case 1, console, hey, TW, right? You chose 1, right? You chose 1. And we're just going to copy this thing, copy, going to 2, and you chose 2, right? 3, we're just going to exit, so we're just going to do a CW, right? And if it's the default case, if they enter something else, right, we're going to do incorrect entry, try again. Because it's incorrect. If it's not 1, 2, or 3, they put something else in. The menu doesn't cover that, right? And maybe we need some kind of console.write up here. Console.write, not a write line, that basically says, please make your selection. Okay, does that make sense? So we're going to ask for the menu item to be here. And it's going to loop. It's going to come up here. Boop. It's going to loop. It's going to go down. You're going to make your selection. It's going to say you chose 1. So you know what? After this, we're going to give a bit of a space. Console, so CW. And after the space, we're going to add in another little one of these. Just for more formatting. Because formatting like this, console.writelines are free, right? That's it. You can make your choices. And you know what? We might as well add one over here. Why not? just to make it nice and even like, and press save. Menu. This is part of your assignment number 4. The only thing is I'm using a do while loop and you guys are using a while loop. Right? Do while loop, difference between a do while loop and a while loop. Do while loop always works at least once. Very few reasons to use a do while loop though, but a menu is a really good reason for one. This is a very good structure for menu because you want to at least display the menu once, right? So it's better than a while loop for that reason, okay? But we're going to ask you to do a while loop. Yeah.
Can you just commit to, or like?
Yeah, sure.
Just so I can catch up to you guys.
I know I'm a little fast today, but bear with me. So I'm going to go home, change, and I'm going to say added menu and switch, using switch and do loop. Commit, home, unsync commits, sync. You should have it now. Make sense? So now let's see what happens with this thing. So I'm going to go press play. Hey, I got my menu. First choice, second choice, and exit. I go first choice, 1. You chose 1. Oh, man. What the hell? I chose 1 and I got my menu again? I don't want that. I want my choose 1, and I want to clear the screen after I make my choice every time, right? And then display my menu. But I want to give a bit of a pause, right? That's not exactly what I wanted. So I know I chose 1. I got my space going on, right? This is important. I need to do a read key after every one I do. So that if it's every one I do, right, as an example, except for even my incorrect entry, right, I'm going to have to do this again, this press any key to continue, right? Now I'm doing it down here, but I might as well do it again. So I'm taking this whole thing right here, and I do this thing, this press any key to continue. I'm doing this thing after every one of my choices. Depending, it doesn't matter which one it is, which means it should be inside my while loop anyway. So I'm going to take this thing and put it inside my do while loop here. Right? Why? After I'm done making my choice, I'm going to get this press any key to continue, and when I'm done, it's going to clear the screen and take me to my new choice. Right? This is a better structure. I'm reformatting or refactoring how my menu will work. Let's see how this works now. Okay, I'm going to go like this. Please make your choice. 1, first choice. Here's my, you chose 1. Now I'm going to press any key to continue. Right? Boom, it goes to the top again. Choice 2. You chose 2. Press any key to continue. Chose 3. And I'm exiting. Right? Now this should exit me right away. How come it's doing this? Why? Because it's waiting for me to enter my selection and then out. So maybe what I can do is here I can say thank you, goodbye. Right? Thank you and goodbye. Let's try this out. So again, 3, thank you and goodbye. Press any key to continue. So now we got our menu, and we're using a do while loop instead of a while loop. Do while loop, again, recap. The condition is at the bottom as opposed to the top, right? This is what my do while loop looks like. Here's my while, my condition down here, whereas the do starts off my loop at the top. The curly braces still contain the code block, just like my while loop. Okay, let's swap it out. Let's not use my do while loop. Let's use the while loop instead. Here's what I'm going to do. I'm going to put the while on top. So I'm going to take this statement down here, right? I'm going to cut it out, go to the top, paste it in, all right? And let's see how this works. So while my selection is not equal to 3, well, look, my selection's already been initialized to 0, so it's not equal to 3, which means that this condition is true. I'm going to run my menu. Let's see if it does anything differently. So I run it. I go first choice, second choice, exit. Same. There really isn't a difference in this particular case. But truthfully, for a menu, a do while loop is better because you want to run it at least once. And you don't need to do this. You don't need to initialize it. I don't need to do this. I can take this out. I can not initialize my sentinel variable, this thing I'm checking, with a do while loop. So if I don't have the value of my selection variable, I would use a do while loop. If I have the value, then either loop is fine. Okay? Okay, so that's do while. And again, we're putting our switch statement, which right here, inside of our loop. This is the kind of what I want you to do for assignment number 4, part 2. You're going to make an assignment like this. Is that me or you? Someone's beeping like crazy. Huh? Okay, if that makes any sense, right? Okay, let's go back. So we really covered the do loop, in a nutshell. We kind of reviewed what a while loop is, and we looked at the do loop. And really, again, I'll say it one more time. The difference between a while and do loop is do loop always happens at least once. While loop may or may not happen. For loop you use when you know how many times you want to loop, like 36,000 times. You're going to use a for loop, right? Obviously, in your example number 1, your assignment 4, part 1. That's a for loop you're going to use. That makes sense, right? And here's an example of what the for loop looks like from a flowcharting perspective, or the do loop, I mean. Your loop body is first, right? You do your loop body one time, then you test your loop, and then if it's true, you continue. That's different than the while loop. The while loop tests at the top, the do loop tests at the bottom. Different structure. And let's take a look at this. Here's a do loop, just like we did. So write bank balance is, here's bank balance. This is our what you're looking at is a flow chart, right? We'll go back to the next part. Bank balance is equal to bank balance plus bank balance times interest rate. So you're multiplying your bank balance by the interest rate, right? And then here the next one is write, do you want to see your next year's balance? Yes or no. Get the response and convert it to a character. If the response is yes, here's the do loop, then do it again, right? Bank balance is da 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 da. If it's false, exit. So this is why this works nicely. It's a do loop. It runs, and it'll at least calculate your bank total once, right? It'll go through this menu. That's why it's good for menus. So we've done for loops, while loops, and do loops. But we should really talk about nested loops, right? Why would I ever use a nested loop? When we think about nested loops, we want to talk about things like this. We have the first outer loop condition, then the second inner loop condition, right? So think about an idea where I have to go and talk about X's and Y's. This is a good example of this, or row and column, right? I have 2 dimensions that I want to look at, not just one, right? I want to make a table, right, of values. And my table of values that I want to output, right, is like a row and a column, right? How would I output a row and a column, as an example, right, if I want to do it systematically? So now I have a nested loop situation. Typically, most nested loops are 2 nested for loops, but you can nest any 2 loops within each other. An example is you can have an outside while loop and an inside for loop. You can have an outside for loop and an inside while loop or do loop. You can have an inside for loop, another inside for loop, and another inside for loop. Triple nested loop, right? Why do we nest? We nest because we have multiple conditions we want to take care of. Like we want to iterate. We say iterate. That's just a special word that means we're going to run the cycle of the loop. Each cycle, right, as an example, we're going to run through. And what we're going to do is we're going to move it so that we're going to hit every column in a row. So let's say we have a chessboard idea, right? The chessboard has how many rows and columns? Do you guys know the chessboard? Let's take a look. I'm going to pull up a chessboard online here because looping is really important to understand. Let's take a look. So a chessboard. Okay. If I look at some images, here's a chessboard, right? If you notice, a typical chessboard, this is a good example of that. It has 1, 2, 3, 4, 5, 6, 7, 8 by 8. So you have, here are the rows, right? And here are the columns. So if I want to do things like this, if I start, depending on where I want to start, typically we start, when we do computer graphics, right? Most computer graphics programs, we start at the top left corner. Cartesian math, though, starts at the bottom left corner for 0, 0. So if it goes 0, 0, 0 will be here, then if my x-coordinate goes up by 1, we go to the right by 1, right, in math. And when my y-coordinate goes up by 1 in math, we go up by 1, right, x and y. Well, in computers, it doesn't work like that, right? When we do computer graphics of any kind, we go to the right by 1, just like normal. X is always to the right, positive to the right, but y is positive down. So we go down by 1, which is kind of weird. If you're moving a character and you say plus y, you think in your mind it should go up, but it doesn't. It actually goes down because the screen width, let's say we made our width 8 tiles by 8 tiles, right? It would draw out 8 tiles by 8 tiles, right? Just like we're drawing here, right? So let's print out, and what I want you to do, and let's create a program that's going to print out, you know, each of these squares, all right? But we're going to use symbols, right, instead of these squares. I'm going to go B for black, right, and W for white, right? And we're going to go black, white, black, white, black, white, black, white, and then we're going to switch to white, black, white, black, white, black, white, black. What is this pattern? It means we're going to start each other row with a white, and we're going to do this. We're going to have 8 rows by 8 columns. So at the end, I want to have a pattern that has characters only, right? With no other funky characters. I want to make black, white, just like this chessboard. Can you figure out how to do it? We're going to use nested loops and a nested for loop. So we're going to make a new program here. I'm going to close this up. The solution is done. We're going to do File, New, Project. Right, we're going to do console application. This is going to lead us into arrays because you're going to see how the value of arrays makes sense here, right? We're going to call this COMP100 lesson 8 part 2. More complicated stuff, like I said. And we're going to get into more complicated. This second half of the semester, we're going to get more into more complicated, more interesting things. Okay, you know what? I need my other piece here. Just for the sake of time, I'm going to copy it from my other program. So I'm going to go into GitHub. I just created COMP100, right? Lesson 8, part 1. I'm going to go in there, and I'm going to grab my this piece here, so I don't have to do it again. I'm going to copy it as and kind of put it in here, right? So I have that all kind of started off. Yeah, makes sense? So I don't have to type all that crap out again. Let's go into GitHub really quickly, and I'll create my full file for you guys so you guys can follow along. Because this is going to be more of a complicated one, right? And I'm going to go into create new repository. And I'm going to say this. I'm going to say COMP100 lesson 8 part 2, right? And this will cover more of nested loops. Nested loops, right? Create repository. Here it is. Copy it. Oops. Copy it. And then go back in here. Team Explorer, Home, Changes, Created, Base, VS, C# project, right? Commit. And then go Home, Sync, Control V, Publish. Boom. Okay, cool. So now online, you guys should be up to date, right? Here's my project. And if you notice, I say nested loops. I kind of put a little comment in there for nested loops. Okay, let's just kill this for now. All right, so I want to create 2 nested loops. So my output, this is what my output is going to look like. Let's do my output first. Let's do a little bit of some tests. So how do I want my output to look? Let's see, Hattie, what do you think of this? I want it like this. I want it to be so white. Let's make a string. So it's going to be white, black, white, black, white, black, white, black, right? 1, 2, 3, 4, 5, 6, 7, 8. That's what I want my first one to look like, right? So that's the pattern for my first one. And then this is the pattern for my second one. Black, white, black, white, black, white, black, white, right? So there's a couple things we can do here. Depending on what I want to do, right? Here's my first one, my second one, right? I can do the same thing again. I can kind of copy this a couple times. So this is what my chessboard is going to look like. Yeah? That's what I want the result to be. 1, 2, 3, 4, 5, 6, 7, 8. So 8 rows by 8 columns, except they're not going to be strings like this. They're going to be one character at a time. I want you to print out, right? Because this would be easy. I just have to do a loop, right? Do these 2 lines. I can do those 2 lines 4 times. I'm done, right? Makes sense? But that's not what I want. I want each character to appear, right? And I want you to create a loop that goes through, that goes white, black, white, black, white, black, white, black, right? So for a total of 8 characters wide. And then it's going to go to the next line and go the other way. Black, white, black, white, black, white, black, white. And then it's going to keep doing that pattern 4 more times. This is an opportunity for us to do nested loops. So this is my output. I'm going to put this in as a comment, right? So I'm going to go like this. I'm going to say desired output. That's my desired output. Let me get rid of the quotes because I don't want quotes. It's not going to show quotes when we print out, right? I just want this kind of stuff to happen, right? And the same thing goes for the semicolon and all that stuff. I don't need any of that stuff. So I want to kind of format, and this is sometimes good for you guys to do. Figure out what it should look like. What should your output look like before you code? Because that's important because you're going to do a little bit of planning, right, before you start coding. All right, so there's my output, my chessboard, right? Desired output for chessboard, right? Make sense? What do you think? Now, there's many ways to do this, right? First, I think I need to start with a for loop, right? I need to loop, and I'm going to do this pattern: white followed by black, right? So white first, space, and then black. 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 Make sense? So that's for loop. That's a loop that's going to go 4 times. So let's do that first line first. So we're going to go for loop, right? Okay, and I'm going to go I'll say my x coordinate or my row. Here's my row. That's what we'll call it. Int row is equal to 0 until my row is less than 4, right? Row plus plus, right? So my first row. What do I want to print out? I want to do a console.write that shows 2 characters, white and then black, right? And I'm doing that a bunch of times. Let me just go, instead of console.write line, I want to do console.write. Make sense? Because they're going to be right next to each other. And I got to leave some space after my black, white, black, so that I have a space between them. When I'm done looping though, right, I want to go back to my next line. So I know after this loop, I'm going to need a console write line, right? Nothing inside of it. I need that. Why? Because I'm going to go through the loop 4 times. This is my row. Then I'm going to go to the next one. Does that make sense? Okay, let's check this out. Let's see what this part does. So I'm going to run it, and then I get white, black, white, black, white, black, white, black, just like I thought, looping through. Let's make this bloody thing bigger so we can see it. I'm going to kill myself with this color. It's driving me crazy. And it's not because of you guys, it's because, you know, Hey, what happened? No, that was not right. All right. So this is my first row. 1, 2, 3, 4, 5, 6, 7, 8. So I've got my 8 characters across. White, black, white, black. Now I want to do the next one. And my next one I want to do, right, is I want to change it. So instead of white, black, right, for every other row, I want to do, so if, and here's my row is 0 right now, but I'm not really doing rows, am I? I'm doing columns. Column, 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 column. I'm going across. So this is incorrect. Instead of writing row, again, we have to picture it in our mind how we're doing this, right? I'm going to refactor, rename. Instead of row, I'll go column, right? And apply. There's our column. So white, black, white, black, black. And then every other, this is our first row. Every other row, I want to check to see if it's row 0, we'll do white, black, white, black. But if it's row 1, we'll do black, white, black, white. Okay? So every even row. How do we do that? Let's think about that first. So that's a test we're going to do. Let's do the second row. Okay, so let's do this the first row in our columns. We're going to print this out. And inside here, the first thing is we're going to kind of go to the next line. So here's our nested loop. So this is column, right, inside here. Should the rows be on the outside? You'd think it's column or column row. But if I do this way, if I put my row on the outside, here's my outside loop. And by the way, I'm just going to do some coding here. This is my inner loop, right? My inner loop. And I'm going to do a for loop, right? And this is going to be my outer loop, right? Here's my outer loop. Now I need to put my inner loop inside my outer loop. Let's do that. So this is what a nested for loop looks like, right? My outer loop, okay, instead of I'm going to rename this thing, refactor. I'm going to call this row, right? And instead of length, all right, because we're going to do 8 rows, each row is going to be different. We're going to go to 8 rows, right? As long as row is less than 8, it's going to keep looping, okay? So in here, all the columns are going to be done, but every other column, I want to switch. First, let's just do it like this so it's all the same. And let's see what it does. So run it. Bang. We got our inner loop and our outer loop. Take a look. But they're all the same. Take a look, guys. WB, 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 right? Shouldn't be that way. It should be WB, 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 and then on the next one it should be B, WB, WB, W. How do we switch? Well, we got to do an if condition, right? So we're going to say this. We're going to say inside of our loop, we're going to do an if statement. If, right, row is even, if its row is an even number, or if you can divide, it's every other one, or odd, sorry. If row is odd, right? If row is an odd number, how do I check to see if row is an odd number, by the way? I have a remainder, right? If row is an odd number, I'm going to check to see if I have a remainder. If I have a remainder, right, then it's odd. If I don't have a remainder, it's even, and I want to make sure that I show WB, WB, right? So how do I make a remainder? I got to say if the value of row divided by, right, divided by 2, right, is not equal to 0, right? That means it's not an even number, right? Not divisible by 2. Then, if it's not equal to 0, right, then what I want to do is every other row, so on odd rows, I want to do this other one, console CW, right? And it's going to be black, white. Now there's different ways to write this thing, okay? Else, otherwise, whatever else it is, it's going to always be white, black. But it's not going to be based on my column, right? My columns are always going to, it's always going to do 4 columns of this stuff, right? It's going to be based on my row. So if my row count is 0, is it divisible by 2? The answer is yes, right? It's going to get 0. So they won't do it on that one, yes.
Can you spell else by itself?
I did.
Like
Else.
that row.
Oh, I got to do this too. What are you talking about? Well, instead of right, it's not right line, it's right.
Never mind.
It's an if-else statement. These things go together, remember? Okay, let's see if this works. So I'm going to kind of run it and see what result I get. White, black, white, black, white, black, white, black, black, white, black, white, black, black, white, black, white, black, and I get the whole, I got my output. Let's look if what I got here, here's my test, and let's see if what I get matches up with my test. Does it? White, black, white, black, white, black, black, white, black, white, black, black, da, da, da. It does. So how did I figure this out? How did I figure that out? We used nested loops, and I used this percentage. Percentage is kind of funny. It's the modulus operator. We talked about this before, right? It's like division, right? But we're going to say this. Take row. Row starts off at 0. Let's trace this thing. So row is 0. What's 0 divided by 2? Is it 0? The answer is yes. Because it's even, it doesn't do this one. It does this one. So first time it prints off WB, right? Now we do this. Guess what? We do this every time, right? And this is bad. Why is this bad? I'm doing this thing, this check, every single time. Why is this doing this check bad inside here? Is there a better way to write this?
Like more efficient?
Mm-hmm. That means I'm doing this 4 times. Every time I go to the column, go across the columns, I'm checking. Should I check while I go across the columns, or should I check once every row? It makes sense that I would check once every row because you know what? I'm testing for row. I'm not testing for column. If I was checking something every column, it makes sense that I would check inside the inner loop. But I want to check on the outside. I still want a console.write on the inner loop, right? But I want to check on the outside, which lends itself to an option for us to make a variable, right? This is the more efficient way of doing it. I'm going to go string, right? And we're going to say, maybe I'll call this string, it's going to be the chessboard string, right? So pattern, we'll call it string, is going to be called pattern, right? And we're going to initialize pattern to nothing. That's what we're going to do every time round, right? If, here's my if statement. I'm going to copy my if statement for a second. Watch me what I'm going to do, right? If row %2 is not equal to 0, then guess what? My pattern is then equal to black and white, right? Else, oops, if I can do this properly, else my pattern is equal to white and black. And then down here, instead of console.write be white, and this big if statement, I'm just going to go pattern once. Because no matter what it is, my pattern is only going to change once every row change, which only happens a bunch of times. So isn't this more effective? That means, and this is why I'm telling you this is more effective. This way, from an efficiency perspective, I'm only checking 1 time per row. The other way, I was checking 4 times every row. Every time I do a check, an if statement, my cycles for the computer go up. I'm doing something. I'm asking the computer to do something. I'm making it do a condition. Here, I'm only checking once every row, not 4 times every row. So I'm 4 times faster. It'll run, this code will run 4 times faster than the other way. Let's check that. So first I'm going to save this for a second, right? I'm going to save this. And there's two patterns here that I got, right? So I'm going to kind of copy this whole pattern right here, this whole loop, inner loop and outer loop. I'm going to copy this thing. And then I'm going to undo everything. Bear with me while I do that. Here's my undo, 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 undo. Right? We're going to undo this back to the way it was. We're going to take away that string, and we're going to go back to the way it was before. Right? That's how it was. And now I'm going to do the same loop down here. Okay, so there's two loops. There's one on the outside, and there's going to be two chessboards. I'll separate it by console.writeLine. Okay, let's run this thing so you see what I'm talking about. Two loops, one for this chessboard, and here's another one for the other chessboard. Right? Two ways of doing the same thing. One like this, and by the way, from a code count, from a line count perspective, not including spaces, if I take away spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, sorry, 17. So this has 17 lines in it. 17 lines, right? And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 lines. Now you'd think the 15 lines are going to be more effective than the 17 lines. Yeah? Not so. Because here I'm checking, because I don't have my, I'm actually adding a couple things in here. My string pattern is the extra line, right? I'm adding that in. And what I'm doing is, that's one of my extra lines that I'm putting in here, right? The rest, pretty much, I've just taken this stuff and put it out here. And I'm actually assigning it here, and I've got this extra line in here to console.write, where here I console.write twice. Okay? So almost identical, you would say, right? Let's do a test. Well, there's this new thing that's part of our looping PowerPoint. It's called, I can do something called using, I put a new using statement, and I can do a system.diagnostics. Let's do a diagnostics. Okay? So what's this using thing do anyway? Do you guys remember? Using, when I use the using keyword, right, in my code, I'm actually asking the computer to import another library. Even though I'm using C#, C# has many, many libraries, right? And what this does is it allows me to add in additional functionality into my code with built-in libraries. So I'm just going to add in the diagnostics library. The diagnostics library allows me to do testing. So I can actually test how long each thing takes. It's very, very key. Yeah, hold on a second. Let's do the commit. I know you guys are behind a little bit. I'm going to go changes. I'm going to go added second chessboard. That's what I did here. And I'm going to say yes. I'm going to go home and then go unsync commits and sync. There we go. Now you guys are up to speed with me. Okay, so I'm adding a diagnostics. That's what I'm doing here. Let's go back to the PowerPoint to show you what I'm doing. So I'm kind of doing something called loop efficiency. That's what I'm checking. Okay, so I'm not going to do accumulated totals here. I'm doing improving loop performance is where I'm at. Take a look. This is the PowerPoint section I'm on right now, if you're following along with the PowerPoint. So one thing I can do is I can meter myself from a performance perspective. And this is how I do it. I create something called a stopwatch. It's almost like a count. I go, okay, click the stopwatch on. How long will my loop take, my cycle? How long does the cycles take? Okay, stop the stopwatch now. How long did that take? Okay, now measure the beginning from stop to end. It measures it in milliseconds. And now print out how long it's taken me to do that loop. Okay, it's really cool. So let's do that. Let's create a couple of stopwatches, right? I want to create a couple of stopwatches up here inside the top of my code. So I'm going to say stopwatch, right? My stopwatch is going to be the first one which is, I'm going to go cycle, I'll call it loop 1, my loop 1 stopwatch, right? And that's the first one, right? And in my loop 1, I'm going to say is equal to stopwatch dot start new. So I'm going to start a new stopwatch at the top of my code. You watching, Hattie? Here's my stopwatch at the top of my code. I'm starting a new stopwatch. And I'm going to do the same thing for this one, this pattern over here. So here's my next stopwatch. Instead of loop 1, I'll call it loop 2. Right? Stopwatch loop 2. Here's my stopwatch loop 1. So I'm going to start counting. Right? Milliseconds. Right? And at the bottom of my code, after the outer loop is done, which is down here, I'm going to go loop 1 dot stop. So I'm going to stop my stopwatch. So I'm going to start it, stop it. I'm timing myself how long these things this is going to take. I'm going to do the same thing on the bottom of loop 2. So here's my loop 2, right? And here's my stopwatch. So I'm going to say loop 2 dot stop. And what this is going to do, so here's the start. So start counting. Start counting. And then down here is stop counting. You know what I'm doing here? I'm measuring. I'm doing some diagnostics. I'm metering myself. Stop counting. And I'm measuring each of these loops. Start here and here, right? Start here and here. Okay, now I want to print out my results. So what are my results of my loop 1 and loop 2? I'm going to do a bright line, right? I'm going to say loop 1. How long did it take? It took this many milliseconds, right? And I'm going to do this. By the way, the code is right here for you guys to see. It's stopwatch dot or whatever the loop elapsed in total milliseconds. So in this particular case, it's loop 1 dot elapsed and dot total milliseconds. Sorry. Here's what it looks like. Make sense? Loop 1 elapsed total milliseconds. So this is going to give me the total milliseconds it took for my loop 1 to finish. And let's do my total milliseconds it took for my loop 2 to finish. Here's my loop 2. Just going to change one item, right? And I'm going to commit this to GitHub for you guys. So go back here, Team Explorer, Home, right? And I'll say added metrics, loop metrics, right? Commit, Home, unsync commits, sync. Cool, cool. So I got my loop metrics here, right? Let's see how long it took. Ready? Run. Boom. Loop 1, this first one, took 6.1122 milliseconds, right? Loop 2 took 5.209 milliseconds. Obviously, loop 2 is more efficient. Took less time to run.
So if we're talking about like a big, huge game or whatever,
It's huge. It's huge what we just did. Huge.
Like it saves for like power.
It saves cycles. Imagine if I'm checking something 60 frames per second, right? If I can save 6 milliseconds per frame, it gives me that much less lag, right? It's huge. It's really important. So the way we do our loops, loop counting is super important for us to meter. How fast we're going to do stuff. We just add an extra little bit of a console.writeLine command here, right, just to give it a little bit of a space. And you know what? Let me just add in some stuff around how long each thing took. I like this thing here. I like these little console.writeLines. So I'm going to copy this just to pretty it up.
How do you get the color code? The lines, light blue.
Oh, this is just me. This is just my my settings for my editor.
Okay.
I'm not sure if you have that capability. My editor is slightly different than yours. 2013, mine's Ultimate, and I've set things up. But for me, if you want to look at the tools, I go to Tools, Options, right? And under if I'm not wrong, if I go to text editor, I have drag and drop text editing, automatic delimiter highlighting, track changes, auto detect UTF-8 encoding with signatures, selection margin, indicator margin, and highlight current line. Do you have all that?
I haven't seen it.
Right. And the next one is if I go into my C#, I have auto list members, parameter information, word wrap, line numbers, enable single click URL navigation bar, automatic brace completion, and apply cut or copy commands into blank lines where there is no selection.
Oh, it was word map that I didn't have selected.
Word wrap is just showing
Word
me.
map, sorry.
That doesn't do that though. That's just me word wrapping. So when my lines are too long, it wraps. You don't want that. If I go to advanced, here's some other stuff. Enter outlining mode with when files are open. Editor help. Underline errors. Show live semantic errors. Highlight references as symbol under cursor. Let me see. Warn if there are compiler-generated references. Generate XML documents. Warn if build errors occur. I don't need that. How about formatting? Automatically format completed statement in, on, semicolon. Automatically for completed block on, brace. Automatically format on paste. And then let me see, spacing, wrapping, indent block, new lines. Like I'm saying, it's somewhere in here. Like one of these options I turned on shows me the lines that come down. That's how complicated. There's so many options, right? One thing I would also ask, I'll always ask you to turn on is to turn on line numbers. That's huge. You should always turn on line numbers when we work together, right? So if you enable line numbers, that way we can see, I can say go to line 13, go to line 14. It's easier for us to do that. Okay? But it's somewhere in here when you look at these lines. That's all it is. And the other thing is if you look at environment, if you click on environment, guys, I'm set to my colors. My color theme is blue, right? You can choose different color themes, blue, dark, or light. Which one is you? Which one are you using?
Blue.
Blue. Okay, and also from a text editor perspective also, mine's blue. You can also see that my text editor for C#, I can choose things like font sizes and all that stuff too. Like if I go back down to text editor, C#, actually if I go general, and here's my file extension. I added in EJS to my text editor, and I've got some other things that work for all languages. Here's my scroll bars, here's my tabs, here's my code lens. All this other stuff here, right? It's mad. Like literally so many things you can look through to see if it's one thing or another. Like tons and tons of stuff. There's debugging, different debugging things. Enable address level debugging, enable breakpoint filters, enable line, the exception assistant, enable just my code, stop over properties and operators, right? There's just so many things, so many things. Text templating, stuff for Web Essentials, and update 3. There's tons and tons of things. Okay, let's go back though. I'm just going to go press OK here. I'm going to go back, and if I run it again, let's look and see this if it's the same result. 5.981, 5.1511. So 5.9, almost a difference of 8.8 milliseconds. Not quite a millisecond. How many milliseconds are in a second? This is important if you're ever going to game. You do any kind of gaming, huh? 1,000. So that means like 5, we're talking about less than, 1 out of 1,000, right, is what we're talking about in speed because our computers are fast these days. What numbers do you have? Do you have something similar to me? Is yours slower than mine, your computer? This tells you your CPU speed too, by the way, and the RAM you have and all that. I'm running mine in a virtual machine, right? So my virtual machine is running 5.9 milliseconds for that first loop, and for the second one it's 5.1. What are your numbers?
Yeah, 2.072 milliseconds for loop 1 and 1.61 for the second millisecond.
That's right. You have better efficiency and you're looping because me, I'm running in a virtual machine. So mine takes a little longer. I don't have the same computing power that you do, right? When I'm running in my loop than you, as you do. You can run yours way faster than me. So think about that now. If that's true, from a computing power perspective, you guys should all have the same thing. How about you? What's yours?
Well, I'm a little bit behind everything.
Behind. No problem. How about Heidi? What are you getting? What are your numbers?
I haven't added it yet.
Jesus, man. Come on. Catch up, for God's sake. Let's try this again. Here, I'll run it one more time. I'll run it again. This time it's 5.3 and 4.7. Look how changed that is, right? It's even better than last time.
It was 6 point something.
It was the first time. Let's run it again. I'm going to run it more time. Maybe it's going to get better and better. 6.3, here's the difference, and 4.9. How come it's always different, guys? Tell me. Can you tell me why? For me, it's always, is it always different for you too? Do you know why? There's a lot of different processes going on all at the same time for your operating system. And your operating system, Windows 7 or Windows 8 in my case, is trying to balance the demand you're putting on the system in addition to everything else, all the other services that it's running in the background, right? That's why it's happening the way it's happening. If you do something really intensive, like something else really intensive here, in addition to doing this, you'll see that it slows down even more. So we talked about a couple things this time. We're going to stop the recording for now and take a break. Right? We ran on for a bit. Right? We talked about a couple things. And here's my desired output. I think it's important for you guys to do this desired output stuff. Like, check out what you're looking for. Can you match up for your test case? This is your test case. You know, this is what I want to look like. And how do I format my loop? Even though this looks uglier and there's 17 lines as opposed to 15 lines, this one works more efficiently. Can you think of an even more efficient way of running this stuff, right? Here's what's really bad, and this is from a best practice perspective, what they tell us not to do when we're looking at loop performance. Let's take a look at hints to do things better. One thing, here's my initial solution, right? X is less than A plus B. What am I doing here inside the loop? The loop body or the loop test. What am I doing here? I'm doing a calculation. I don't want to do calculations inside my loop test. That's wrong. That's going to really slow me down in terms of performance, right? Here's a better solution. Do the calculation outside once and then check for it every time. You don't want to calculate in here. That's crazy. It's crazy inefficient, right? Every time I calculate, imagine that. If I loop 1,000 times, and every time I loop, I'm checking what's A and B. I'm adding A and B together every single time. A and B, A and B, A and B, A and B. That's an extra load for the CPU. Makes no sense, right?
Does that work? Does that go for 4 as well?
What do you mean 4? Everything.
4 loop?
Any kind of calculations you do within your loop. Like, for example, if you're calculating length, you know, when we do whatever the length property is, if I want to do a length property of something, I want to calculate the length of something in my loop every single time. It's taking cycles. Makes no sense. Here's another one. Here's an example. A user is to enter a number of printed copies desired between 1 and 15, right? The user is more likely to enter a value than greater than 15 than a value less than 1, right? Use the following test to the user's input. While requested number is greater than 15 or requested number is greater than 1. Okay, think about the order evaluation here. I'm testing this. If this is true or this is true, then the whole thing is true. If it's an or statement, right, do I want to make the test over here for the requested number is equal to 15? If I'm going to choose 15 more often, chances not, because it means I have to do this one and I have to test this one, right? Because either one or the other is true. And if it's more likely that this is always going to be true in here, right, then I want to test this one first, because that means I only have to do one test, not 2. If I have to always do 2 tests, that's half as slow, or half as fast, if you will, right? So the order of checking for your testing is also important. If I'm doing a compound if statement of some sort, if this is greater than this and this is greater than this, both things have to be tested. That's another one. If I have an and statement, one of them fails, both fail, right? I want to put the one that's going to fail the most likely closer to the first test. Why? Because if this one always fails more, then it'll only check one. If I have to check this one over here, the second one, like let's say if this was an and instead of an or, that means I want to make sure that this one is the one that fails the most. If it's an or, I want to make this one the one that always tests positive, right? The first one, so I only do one test instead of two. Always, always, always. Think of it like that for test efficiency. Because loops is where we lose a lot of efficiency. And the other one is this, comparing things to 0 is way faster, right, than making a comparison to any other value. That's just the way loops work. Let's check that out. So here's a loop, and I got a couple of loops here. I got the first one that says for int is equal to 0, and then I'm going to check to see if x is less than this 10 million number, right? I'm checking to see if x is less than 10 million. Okay, cool. Here, I do the other way around. I start high, loops, and I check to see if x is greater than or equal to 0. And I decrement, I go down. This is more efficient. To check that, this is something we can do with our own loop because we're using 2 for loops. Let's see how we can do that here. So I've got 8. I'm checking to see if row is less than 8. I can do it the other way around, can't I? So remember, my numbers were like 6 and 5, or between this one was like 6s and 5s, right? Yours was 1s and 2s, right? But mostly 2, around 2 milliseconds, right? Mine was like 5, 6 milliseconds. Let's see what I can do here if I take this and do it the other way around. Now, remember, I'm still looping the same number of times, right? But I'm starting off. I got to have the same result too. I got to watch this, right? So I want to start off at 8. Which is going to be an even number, right? And I want to say as long as row is greater than or equal to 0, right? Until row is greater than or equal to 0, right? If it's less than 0, right? I'm going to go row minus minus too. Look, row minus minus. So that's going to count down, row minus minus. Okay, same thing with this one. I'm going to go column is 4, and I'm going to count down until column is greater than or equal to 0. It's my comparison. Column minus minus. So I'm actually counting backwards, right? Column minus minus. Okay, so let's see if this messes me up. Let's run it like this first. Boom. Bam. Okay, it did kind of something weird, doesn't it? Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Didn't quite do what I wanted to do. And then this 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7. That kind of messed me up.
Is that because the if statement? Because it has to do with the if?
No.
No?
Nope. Has to do with my counting. So I'm starting off at 4, right? And I'm going 4, 3, 2, 1, 0, 5. That's wrong. So instead of greater than or equal to 0, I'm going to go as long as it's greater than 0. Right? Same thing here. Let's see if that makes the difference. Run it. Yeah, baby. Okay, now look at the difference. Look at my number here. My loop 1, which is the most inefficient loop, drops down to 4.6. Right? This one was the more efficient loop. It's now the least efficient loop. Just because I compared it to 0, man. That's the difference. That's power for you. Right? So always comparing a number to 0 is way more efficient. And not doing calculations is way more efficient. And working out stuff to not do, try what can you not do in the loop to make yourself more efficient. That's really key. Let's do the same kind of thing down here to make our bottom loop even more efficient. Do the same thing. So say row is equal to 8 as long as row is greater than 0. Right? Row minus minus. Right? Same thing here. Right? Column is equal to 4. Column is greater than 0. Column minus minus. By the way, this is true for any programming language, not just for C#. Okay, we did. I was at like better with my other one. Let's see how fast this one is. Run. Let's see if I get the same result first of all. Boom. Okay, now it's more efficient again. Let me run that again. So now it's 5.3 and 5.0. It's closer. Let's run it again. 5.4 and 4.1. Woo! What a difference. I'm in my 4s now. What are you at? You should see more efficiently. Yeah, one still see more efficient loop, right? Now here's like 4.9 and 4.4. So I'm consistently getting in the 4s, right? Run it again. 5.4 and 4.7. Okay, here's one thing I want to do, right? I want to run this loop, these two loops, over and over again 100 times, right? And what I want to do, right, for this stopping and starting is I want to take this number, this, final number, this that I've got here, this elapsed time in milliseconds, and I want to add it on to my total time, right? So in total milliseconds, I'm going to add it on. So let's do this. At the top of my code, I'm going to create a new variable, right? 2 new variables. One of them is, they're going to be both, now again, this is total time in milliseconds. So they're going to be integers. Let's see if this works. First of all, they're both integers, right? I'm going to say, loop 1 total, right? I'm going to initialize that to 0. And then loop 2 total, I'm going to make that 0 as well. So I got loop 1 and loop 2 total, and right now they're zeros. Okay, cool. So when I go down to loop 1, here's my loop 1 start, right? And here's I'm doing my calculations down here. When I do my calculations outside of the loop, I'm going to say at the end, before I loop again, right? Loop 1 total is equal to loop 1 elapsed total milliseconds. Sorry, I'll bring it up for you. Right? Now let's see if I can do this, because loop 1 elapsed total milliseconds is, it's going to say, hey, it says cannot implicitly convert type double to int. So actually, instead of loop 1 total being a loop 1 total being an integer, let's make it doubles. So that was doubles that we need, not integers. Okay, double. Okay. And what I'm going to do is I'm going to say, I'm going to add in my total number of milliseconds here in terms of the whole process, right? So I'm going to do the same thing for loop 2. Okay. And now I'm going to print out a console.writeLine, and then my totals again. So loop 1, my totals, and by the way, I'm going to go like this. Instead of equals, I'm going to go plus equals. What does plus equals do? Remember? Plus equals? Plus equals is like saying loop 1 total is equal to loop 1 total plus loop 1 elapsed total milliseconds. That's what, it's a shortcut for that. All right, I'm going to do one of these. I'm going to put one of those as a decorator. Let's put a decorator down again. And then I'm going to print out my couple of these things again. So these things here in milliseconds. Let's see if I can do this. Not sure if I can. Guys, just bear with me while I do this. Right? So here's my 2 things here again. I'm going to take these and put them down here. Instead of saying loop 1, I'm going to say loop 1 total in milliseconds. Loop 2 total. Right? So my totals are going to go up. Right? So it'll be more effective this way. So I see the total number of milliseconds it takes to run, let's say 100 times. Right? And I'm going to run this. So if you notice, my loop 1 elapsed total milliseconds is not what I want down here. I want my loop 1 total and my loop 2 total down here. So loop 1 total, right, and loop 2 total. If you see what I'm saying. Okay? So all I'm doing is I'm calculating how many of these I'm getting. Okay, now this is, I've got two outer loops. I got an outer loop and an inner loop, an outer loop and an inner loop. Let's do an outer loop. Real nested loop shit. Sorry to say it that way, but this is crazy. Let's run the outer loop, right? Hold on, I'm not finished yet. Let's do the outer loop, right? Let's do my outer loop. We'll run it, like I said, 100 times. So we'll say, okay, I'm running it 100 times. I'm not going to test my outer loop how long it's going to take, because that's going to take long, right? But if I want to run my outer loop, I'm going to say for, I'll leave it as I for now. Well, where I is less than 100, which is really inefficient for us to do each of these, okay? But I'm going to take this whole thing from where it says stopwatch all the way down to the bottom to here, right? All this stuff. Take it, I'm going to cut it, I'm going to put it inside my loop. Okay? So now I got a loop within a loop within a loop, 3-4 loops in a row. But it's going to do this 100 times. So I'm going to do 100 one of these things, these loops, right? So I'm really taxing the system. Let's see if I can do this thing. Yeah, okay.
I want to try to.
Man, take my fun away. Okay? Added another outer loop. Okay, commit, home, and I'm going to go to unsync commits and sync. Okay, and then press play. Let's try this out. Boom. Okay, my total number is 591 milliseconds for loop 1 and 605 milliseconds for loop 2. But you'd think it'd be more the other way around, right? Let's try it again. Did you guys get that? So, bam. 609 and 584. So that was a little bit of an anomaly. 609. Look at the difference in milliseconds between one and the other. I've got almost a 20 millisecond lag between one loop and the other, over 100 loops.
Do you think it's possible to do the first, like for loop number 2? Do you think it's possible to
make it even better?
Yeah.
To
make make one even worse.
I could totally make it worse. I could totally make. Look, the more calculations we do in the header, the worse it is, right?
Like for loop number 1, you changed it to comparing it to 0, right?
Mm-hmm.
You should have only done that for. I mean, I wanted to see.
Well, I also did both loops. Both the outer and the inner loop I changed to 0. I could do only one loop and not the other loop, right? There's all kinds of control, right? So this is a good little test for you guys to do, right? Here's one that I want you to think about. So I've done 100. Let's go to 60. So imagine if we're doing 60 frames per second. These are 60 cycles. So I'm checking 60 times a second, okay? And I've got two different sprites that are moving across the screen, two different objects in my game, right? That are moving across the screen, and I run them. And one is cycling in one way and one is cycling the other way. Guess what? In this particular case, my loop 1 is running 367 times, and my loop 2 is actually less efficient, 378 times. Why? Because of the way my processes work. They're very close. Right? There's something in the 360 to 378 range. Now, this is the first time it did that, right? Let's do it again. Mostly, it should be the second one should be more efficient. See, most of the time, 364. Sometimes it won't be because there's other processes going on in the background that's changing my loop count. Let's try it again.
I got 97 and 94.
Yeah, of course, because yours is like, you're not running a VM, right? I'm running a virtual machine. Mine's obviously going to be at least 3 or 4 times slower than yours. Gotta be, right? How about yours? Are you running a VM? What's your speed? How much? 15 for each one, right? Yeah, 3 times slower than mine, right? And what about when you do the totals?
Loop 1 is 1374.1734.
Shh.
0 is 1332.34.
See what I'm saying? 13,000 like milliseconds. So 1.3 milliseconds. Yeah, 1.3 seconds.
Oh, yeah.
Right? So look at this one. Here's 364 and 377. Right? Let's try it again. So that's the difference between and also your computer is using different computing power than mine. Here's one where the second one ran over, 402 compared to 372. Right, but most often, I've got a better average, right, with my first one compared to my second one. Here's another thing I can do. So I've got my computing power going on, my calculations every time, right? I'm doing these calculations every loop, right? What about doing this? At the bottom of my loop, my outer loop, here's my outer loop. Outer loop, all right? In my outer loop, right, when I'm checking, how about if I do an average? So I've got my two loops here, and I know my total. What about my average number of milliseconds for each of them? That's more efficient, or more telling, if you will. So I'm going to do two more doubles, right? My first one is going to be loop 1 average, right? I'm going to say that is equal to 0 at the beginning. And double loop 2 average. How do I calculate averages? Remember? Take the total number of cycles and divide it by my total. I've got my total. I take my total cycles, which is 60. I divide my total by 60, and I've got my average. Right? And that's really what I want. So I'm going to say, I'm going to do another one of these. Right? So I'm going to say this. I'm going to say loop 1 average, right? I don't want it to equal. I want it to equal to loop 1 total, right? Divided by the number of i's that I go through. I means the loop. And I'll change that I to make something else. Loop 2 average, and I'll update this in a second, divided by loop 1, loop 2 total, divided by I. Okay, so what's the I? I is this outer loop. So we're going to call this, we're going to rename this I. I'm going to refactor, rename, and we're going to call this outer. Right? So I'm going to go OK. And press apply. So here's my outer, here's my column, here's my row, and down here I've got my loop 1 average divided is equal to my loop 1 total divided by my outers. It's going to change. So it's going to start off, my first one is going to be 0. That's bad, right? Because my outer starts at 0. So I can't do that, right? So I got to do my outer plus 1. Because if I divide by 0, I'm going to get a divide by 0 error. That's bad. So I got to do outer plus 1, right? So I never start at 0. I start at 1, right? Because my first one, even though I start at 0 here, take a look. Outer is 0. Outer is less than 60, right? As an example, and I divide. It makes more sense, right? Outer plus 1. Okay, let's take a look and see what that does. First, I'll update your little updates. Updated, added averages. Added average. Loop average calculation. Loop average calculation. Commit. Home. Sync. You should have it up on GitHub now. Okay, let's run it. Bam. Okay. That's cool. I did it, but I didn't print it. That's not good. I got to do one of these. Sorry. Forgot. I was too excited. I love stats, right? So loop 1 average, I want to put those in here. And loop 2 average, I want to put over here. Look how many more things I'm printing, right? And instead of loop 1 total, it's loop 1 average. Let's put AVG for average. And loop 2 average. Okay? In milliseconds. Let's try this again. Bam. Okay. This is interesting. I got like crazy numbers here, but you tell me. So my totals start off, my first loop, my last loop I did was 5.3192, and my second one was 5.4. But look, my second loop, even though it should be more efficient, is actually less efficient. Look, 6.85 and 6.66 in this run. My first one was 334 milliseconds and 345 milliseconds, actually slightly longer. Okay, let's try it again. So press space and run it again. It's very, very close. Okay, here's my average now. My average is 7.16 milliseconds as opposed to this. So this actually, it got worse. At some point it lagged. And if you notice the lag, there is a bit of a lag. Watch the lag here and see if you can figure it out, right? Take a look, guys, watch. Watch my computer. See that? It's kind of slowed down and kind of lagged. Why? I'm running a virtual machine. So even though it starts off around 5, there was a bit of a lag in the middle. It took me to about 7. That's for 1 second. So I ran 1 second, right? 60 times. And it took me about 7 milliseconds on average. The average time I took actually took me less than a second. Look, I ran this whole 60 frames, as an example, in 300 milliseconds, which is still 1/3 of a second. That means for me to run in this whole second, I could rightly run 3 times 60. So 180 times would be average for me. How many times can you run in a second? So my maximum number will be around 180 loops. Right, let's try that. So I'm going to stop it. I'm going to go to the top instead of 60, right? I'm going to change this number to 180. And then we'll stop, because I've gone way over it. Here's 180, and I run. Wow, there's more of an average. So I've got the total space is about a second now it took of time. Look, 1,014 milliseconds for 180 loops. Put 180 loops together. And 6.6 was my average loop time for loop 2. My latest loop time was 5.5, the last one I did, with 5.6 for loop 1. But my average is 6.6 milliseconds. What does yours look like? Yeah, what's your average? And what is it? What's your latest one up here? So there's a bit of a lag in the middle too, isn't there, for you? So you're running stuff a bunch of times. There's other processes going on in the background. You're running a program that really runs fast, right? I'm running, so I think about this, I can run 180 frames, if you think about it, cycles per second. I can run that fast. I'll never need to, though. In most video games, if I ever play a video game, the fastest that I'll ever need to probably go is between 60 and 65 frames per second, ever. That means I can easily accomplish my 60 frames per second goal, even with my virtual machine. How about you? Can you do 60 frames per second with your virtual machine? I did 180 loops. 180 loops. How many? Now you don't have to do 180. You do something. Tell me how many loops you can do. If you do 180, right? How long it took you? How many milliseconds in total? Mine took, for 180 loops, it took me roughly a second. What did you do? What did you do for 180?
It took me 280 to 275.
Okay, so you still have 3 times that space. So I want you to multiply 180 by 3. So it's 360. So that's 460. It's 540. Go 540 loops for you. This is the difference between using a virtual machine and not. He can do 540 loops. Now I got 16 gigs of RAM on my Mac, right? But I'm running a virtual machine, and I'm using 2 of my cores to run my virtual machine. 540 at 540. Go to 600. 600 loops. I can only do 180 for 1 second. He can do 600. He can do almost 3 times me. Actually, more than 3 times me. Look, even better, even more efficiently. Okay, so now go to, what were you at? 600? Okay, go to 800. 800 loops. How about you, Hedy?
I have.
So let's go down a little bit. Go to about 780 loops.
I got 900 there.
900 loops?
900.
Yeah, so that's what I'm saying. So it's around.
For the totals or for the average?
The average is, I'm looking at the totals. Well, your totals should run around 1,000. Let's try and make it so that your totals runs around 1,000. Adjust your numbers to make it run around 1,000 every time. Mine's around 120, right? And then I can only do 180 loops. So 180 loops for about 1,000. Just roughly.
I did 950 loops and I got 1,100 for loop 1 and 1,000.
How many? 900?
950.
Wow, that's great. See how fast that is compared to mine and his?
Weird.
No,
It's
but
in the computer.
no, it's not. He's using a laptop.
Oh, he's using his laptop. Oh.
Yeah.
That's
Neat,
cool.
isn't it?
Yeah.
Let's try it again one more time. So here's mine, 180 loops, and I'm doing mine in roughly just over a second. So I can't even do 180 loops. I'm gonna drop that number in a second. Right?
Can you do like 1,000 loops and see what happens with the crash?
Oh no, it won't crash. It won't crash.
I'm gonna try 1,000 loops and see.
So I'm gonna do, let's say, 170 loops. Let's see if I can do 170 under a second. Okay, so I'm gonna go 170. Just marking down what my last test was. So I'm just under. Okay, so let's try 175.
I did 2,000 loops and I got 2,200.
Yeah, so that's about, like you said, about 1,000 loop, almost 1,000 loops per second.
Yeah.
So I'm still better. Look, I'm just under 900 for both. And let's go with 178. Close. 178. That's the best I can do in that range within a second. See, not even that. So roughly maybe 176. I'm readjusting. I'm kind of really metering here, right? And that's not including my outer loop. My outer loop is very inefficient, but I don't care about that, right? I can improve my efficiency by changing my outer loop now. Watch. Okay, that's about right. So I can do about 176 loops for about 1,000 milliseconds, just roughly, give or take.
So you can make this more efficient?
Yeah, let's do the outside. The outside right now is running like this. Look, my outer loop, starting at 0, and I'm comparing it to 176. I can do the same thing I did last time. I can go the other way around. But here's the challenge. The challenge is down here, when I do my average, I can't divide by outer plus 1, right? That won't be efficient anymore, right? Because when I divide by outer plus 1, it'll go down. Like it'll start, my loop average will be off, right? So what I got to do is I got to actually either two things, create a second counter or just put a hard-coded value in here. So in other words, if I want to loop 176 times, I'm going to be 170. I would put 177 down here. Just instead of making a calculation. So I'll put 177 down here. Take a look. So instead of doing a calculation like outer, I'm going to go 177. Because I know I can do 176 approximately within 1 second, right? And then up here, I'm going to do 176 loops. But I'm going to start off 176 here. And I'm going to say where outer is greater than 0. Right? And I'm going to count backwards like this. Okay? So the end result is what I care about, right? I don't care about all the other averages. I only care about the end. Let's see if that's more efficient. So we'll run it. And yeah, look at this. I'm getting one of my values under 1,000. And my averages run a little bit better too because my outer loop, my outer loop is more efficient.
This is crazy.
Hey man, I want to show you guys efficient coding.
I want to show you what happened.
Look, I'm under 1,000 for sure now, right? Hold on, one more thing. And now let's do one more thing. So now I can even increase this even more. So I'm going to go back to 180, approximately 180 here. So I can go more cycles for sure under 1,000. Let's say under 1,000. Right? Now because I've increased my efficiency, and by the way, I have all these other calculations here that I'm doing every loop. Do I have to do these every loop? No, man. I can take these out of my loop, and you can see how crazy efficient it's going to be. So I'm going to say out of 180, right, or 181 is really what it is. There it is. And now if I run this again, so 180 loops, back to 180. Can I do 100,000? Not quite. But it is slightly more efficient. But I am doing all these other calculations every loop, right? My outer loops that I'm doing here, right? Even though I'm not metering them, right? I'm causing excess stuff going on in the background, right? I'm actually creating an additional calculation between calculations that the computer has to keep track of, right? So in order for me to make this more efficient, I don't need to do that here. I just need to do it after everything is done. So before this happens. So these averages and this millisecond stuff has to happen. This millisecond stuff, calculating how many milliseconds it took, my totals, that can also happen at the end. But the problem is this plus equals has to be there. I have to keep on accumulating every loop, right? But this, I can certainly take this part out. So let's move this part outside of the loop and put it after the outer loop is done, right? And let's see how I meter now.
Average?
The average, yeah, because it's not going to change. My 181 is not going to change. And all I'm doing is after everything is said and done, I just want to do my average calculation at the end once, not 180 times. All right, let's see if that makes it more efficient. Not really. Let's do it again.
About 233,000 loops.
So I can't do 180. I still can't do 180. It's a little better, but not much. I can probably do 178 now. I've saved a couple loops. Slightly more efficient. Very, very minor, though. Huh? Not much, right? There we go. Probably 178. Oh, just under 178. And I'm only doing this calculation, this average calculation, once. Right? But this is what's killing it, eh? This here. When I'm calculating my totals and I'm accumulating my totals, that's what's killing my looping.
How many loops are you doing?
178. That's all I can do within 1,000 milliseconds within my virtual machine. Okay, that's enough for this. We're gonna stop and take a break.